Hi guys, welcome to the screencast that I promised you yesterday in the lesson. Before we start what we're actually going to go through, i.e. the physiological adaptations when it comes to strength, just a quick recap of what we did yesterday. So we looked at the types of strength. The way we remembered that, the memory methods was MEDS. So you got maximum strength, explosive, dynamic, static and strength endurance. We looked at the factors affecting strength. We used tag C as a memory method for that. Remember, the main part of that was the G and the C. G, genetics, and when we're talking about genetics, we're talking about type 2B muscle fibers. The fact we get more of them makes us more explosive, more powerful, which is a benefit of factors that affect strength. And then the C was cross-sectional area, i.e. the larger the muscle, kind of the larger the motor neuron, which meant basically larger force of contraction is going to happen. So again, that's a factor that affects our strength. From that, we looked at the evaluation methods used to assess or to test our strength. And obviously, you had for maximum strength, you had the 1 rep max test and the grip dynamometer. For explosive strength, you had the vertical jump test. Dynamic was the wing gait, but you don't really need to remember that one. For static strength, there was no measure. And then for finally strength endurance, we had the press up and sit up tests. From that, we had the types of training. So you've got weight training or free weights, multi-gym, plyometrics, and circuit and interval training. Remember, it's important also to remember the guidelines we had for strength, i.e. frequency, which was sets and reps, intensity, percentage of 1 rep max, and so on. So if we're going to move on to what we're doing today, which is the adaptations that take place. Adaptations, again, will take place after about a 12-week kind of program that you're going to have implemented, and that's when you're going to get your significant structural changes in the neural pathways. Now remember, neural pathways is quite important when it comes to strength due to the fact that you get the messages sent to the brain and then from the brain to the muscle. You get muscle and connective tissue as well as metabolic function adaptations as well, and all of this increases the body's kind of like capacity to provide fast, strong and powerful muscular contractions. This is why when we have these adaptations, this is why we want these adaptations for that fast, strong, powerful contraction. And that is what we're going to be looking at today. Now, I'm going to give you them under the changes under neural pathways, under muscle and connective tissue, and under metabolic function. You may not necessarily need to know the different adaptations and what they fall under. However, it is important that you get them down. They may ask you a question on it. They haven't as of yet, but they may ask about neural pathway adaptations. So first of all, this is a quick description of what neural pathway is. You don't need really to remember. It's just a bit of a kind of to jog your memory of neural pathways and what it is. I'm not going to read it. You can pause and read this if you want to, but I'm going to continue ahead. So adaptations to neural pathways. Structural adaptations. So on the structural adaptations we get an increased synchronization and recruitment of type 2B motor units and fiber types. The functional effect, i.e. why does this benefit us? Why do we want this synchronization recruitment? As I've said, it increases the force of contraction. Okay. Another structural adaptation we get through neural pathways is a decreased inhibition of the stretch reflex. Why does this help us functionally? Once again, increased force of contraction from the agonist muscle. So it's all to do with force of contraction, speed of contraction, so on. As it says down here, overall, increased speed, strength, and power output. Neural pathways, structural adaptations, these two, really important. What do they help with? Force of contraction. Okay, adaptations to the muscles and connective tissue. Muscle hypertrophy, i.e. our cross-sectional area increases, and so does muscle hyperplasia. Now, with regards to hypertrophy, what is it? All it is an increased muscle cell size. Okay, so it's the size of the muscle cell increases, and muscle hyperplasia is an increased number of muscle fibers. So the number of muscle fibers actually increases when it comes to hyperplasia. Why is this a beneficial? Why does this structural adaptation benefit us in context to adaptations? Increases force of contraction. As you can see again, force of contraction, maximum explosive training will increase size of fast glycolytic fibers. Strength endurance training will increase size of fast oxidative glycolytic fibers, but mainly force of contraction. Overall, we're going to get increased speed, strength, power output. Okay, adaptation to the metabolic function. Structural adaptations, we get increased glycogen stores. We use glycogen for energy, it gets converted into energy. Okay, we also get an increase in ATP and phosphocreatine stores. ATP, if you need a quick memory jog, is a chemical energy stored as a high energy compound and is used as the immediate source of energy for muscular contraction. Don't get bogged down by that. ATP, always, we need it for a muscular contraction. We need ATP for muscular contraction. Breakdown of glycogen helps us get more ATP. Phosphocreatine gets broken down. We create ATP, we have more energy. The functional effect, increased capacity for high intensity energy production. Again, it's about that energy production. What does this mean? Increased speed and power. Next structural adaptation, we get increased enzyme activity. So increased activity of anaerobic enzymes. If you write it down like that, that's absolutely fine. So this increased activity of anaerobic enzymes, these anaerobic enzymes break down glycogen, phosphocreatine, okay, to create energy. This means we have an increased efficiency of anaerobic energy production. This also reduces the onset of fatigue. Again, increased tolerance of lactic acid buffering capacity. That's structural adaptation, so an increased tolerance of lactic acid and buffering capacity. What does this mean? Increased tolerance and removal of lactic acid. Why is that good? It means we can perform for longer when we actually have lactic acid. This increases our chance of beating a performer that has the same VO2 max as us. However, they may not have a high tolerance to lactic acid, which means we can continue to train, continue to work within that kind of lactic acid zone. Well, they'll peter out and they will fall off basically because they won't be able to tolerate that lactic acid buildup. Increased threshold of anaerobic system, delayed okay, so delayed onset of blood lactic acid. Once again, it means we can perform for longer at the higher intensities because we can tolerate that anaerobic kind of lactic acid that gets created. They are your metabolic functions, and overall, what does it help with? Increased anaerobic fuel stores and energy production. Now, whenever you're talking about the structural adaptations, as we've just gone through, you need to put it into context of performance, of the strength training. Why do we want to get these adaptations? The functional effect is why, and the main functional effects you need to worry about are increased force of contraction, speed of contraction, power output, and increased anaerobic fuel stores. Okay, so how are we going to actually remember this? So describe adaptations to the strength training. We're going to try and actually use this, the memory method, strength. Okay, so hopefully strength, you're turning that into strength, and this is going to help you out. Now, this is where it turns into with regard to sync, tol, rec, and so on. Now we're going to put this into context where I'm going to actually describe each one for you, and hopefully this memory method will really help you when it comes to the adaptations to strength training. So first one, yes, increased synchronization of type 2B motor units and muscle fibers. This actually contributes and comes in with the R, increased recruitment of type 2B motor units, which increases force of contraction. So your brain is switching on more motor units, okay, recruitment. We are recruiting more motor units, which is basically going to allow for a more forceful contraction. Now, synchronizing these motor units, increased synchronization, these motor units are all going to be working together, okay. So synchronization, working together, recruitment, more of us working together, we're going to have a more forceful contraction. So obviously neural, because the brain is responsible. If you remember the motor unit kind of work we did with regards to motor unit muscular contraction, man says all, we're getting larger recruitment, larger synchronization equals more forceful contraction. Okay, the T is increased tolerance of lactic acid and buffering capacity. By completing weight training, you can resist this lactic acid better by the buffering capacity. So other people who start kind of exercise who aren't trained have to stop earlier because they have a poor or decreased tolerance to lactic acid, whereas someone who's trained for 12 weeks will have a larger tolerance to lactic acid, meaning they can perform for longer duration of time. Decreased inhibition of the antagonist, e.g. the tricep acts as a recall for the bicep on the bicep curl. So what we mean about this, after strength training, this leads to a greater stretch of the tricep because it's not as inhibited. It means it can stretch further. This further stretch results in a larger recoil. That larger recoil results in a more forceful contraction of the bicep. Okay, moving down to increased enzymes and increased activity of anaerobic enzymes. This is basically talking about anaerobic enzymes such as PFK, creatine kinase, ATPase. These break down fuels such as our phosphocreatine fuels, our glycogen. This means this allows for a large contraction. Okay, so more forceful contraction. Phosphocreatine, glycogen, they're within the muscle. They're there. We use that as a fuel for energy, but it needs to be broken down by enzymes. We have more enzymes, so we're breaking down more fat, like kind of faster rates. We're breaking down this glycogen and this phosphocreatine to create a more forceful contraction. And then we have increased glycogen stores in the muscle. We also have an increased phosphocreatine stores in the muscle. These are fuel. This is what we use for fuel. So when these are inside your muscle, it allows for a kind of like a more forceful contraction because we have more of it available. Now, increased threshold of the anaerobic system and oblet is delayed. What this means is this plays a huge part when it comes to endurance sports. Hence why here we've got oblet is delayed. It means we get more reps. If we can get more reps into a training session, to a program, we're going to be getting greater endurance, strength endurance. So this really helps kind of like endurance sports. It's increased threshold of anaerobic system, meaning we can work at higher intensities for longer because our threshold is higher. So that's going to help the sports performer. So when you're talking about Mo Farah, who's racing, if he has a high threshold, he's going to be able to train within that lactic acid, and when he's getting that build of lactic acid, he can still continue to train and carry on. Increased hyperplasia, muscle fiber splitting, which leads to muscular hypertrophy, so larger cross-sectional area, more forceful contractions. Now, what I want you to do, this is an exam question that was set a few years ago. Describe the physiological adaptations that you would expect to occur to skeletal muscle after the completion of a maximum strength training program. I want you to answer that and get it back to me. I want corner notes or some sort of note-taking system on these physiological adaptations. Please send a picture of them, email them to me, and also answer this question. Please try not to use your notes. Obviously, if you need some help, go back to them.